Okay. Okay, let me share my screen. Yeah, whole screen. And just to give a bit of motivation, high level. This screen. Double click on it.
Just in this screen. That's
Oh, it doesn't. I see.
double click. Double click. Double click on what? On the screen.
Yeah. So before we start on the topic, I just want to share some high-level resources and pointers because bonsai has been changing a lot in the last year or so. We're now sponsored by kind of a consortium of groups, which include the Allen Institute, include the Zanzibar Welcome Center, Janelia, and yeah, there's a super massive people who decided to sponsor basically directly the development of bonsai and to solve some of the pains that used to be and are still prevalent, which is people complain about lack of documentation, how do I know what exists, how to use it, and so on, and also thorny things about how to make if you're growing experiments to the scale, because for example, at the Allen and at the SWC, they're now building really large scale experiments. In when I say large scale, I mean numbers of hardware connected to the same computer. You have like now dozens and dozens of cameras and many like large arenas, like 2 meters, 5 meters, whatever, like big things with that run 24/7. And when you build workflows like that, like the way that they scale is quite different from the kind of small one box. That's a good point. It may be mute. I know I muted myself, so it should be. I am unmuted, I think. I am unmuted. Yes, I am. But we can't hear anything because we can't record, but it should be in the recording. What if someone wants to test? Hello?
You're there.
Yeah, I'm there. Oh, he's unmuted. Okay, okay. Doesn't give any feedback. It's
Yeah,
huh?
it's talking.
Talking. Okay, good.
Yeah.
Okay, good. Where was I? So, yeah, this is just to say that, yeah, that support has basically helped us focus a lot of time and attention to improving the basic infrastructure of bonsai as a whole. We're still in the process of putting it out there in the documentation to kind of reflect how much has been done. Actually, there's lots been changing. Just briefly in these 5 minutes, I just want to show a few pointers about where you can find it while it's not very prominent in the page, but there's already places where you can start this coming up. And one is if you go to GitHub, this is just a simple thing, but you see on the repositories, there's now these little tags. Okay, they seem very inconspicuous. They will be more prominent in the website going forward. But if you click on this one, Bonsai RX, you'll basically go to a topic, GitHub topic. It essentially lists all the repositories that have been ever developed for bonsai. And I think they're ranked by stars or activity or whatever. So we have bonsai and deep cut are the most popular, then Vision after, in terms of stars, just counting stars, and harp. But then if you go down, you'll see like sleep. This is bonsai Onyx 1 is the OpenEFIS Onyx, Python scripting, machine learning, harp Python, Spinnaker, video SGN Lab, Jack, Brainflow. Then you'll start noticing very weird things that you might not know bonsai could do, like RealSense 3D cameras, or I don't know, Sapera, CLI multicam, device range pump, physics, TLD, ZMEA. So I'm just saying, like, if you are curious about quickly scanning what's like currently, this page is not a bad page to kind of visit. Just you'll see a lot of stuff. That's one thing. The other big change is for most of these, but not all yet, they now have always a documentation site attached, which is always organized in the following way. So it's always mosirx.org / the name of the repository. And that will throw you to a documentation page for that package. So no promises that it will be enough to understand what's in there, but you say this will be the infrastructure going forward as we populate these things. If you come across any package, and by the way, these packages should also, let's see if this works. If I go to Bonsai proper, Bonsai quickly. If I go to Bonsai package manager, so these packages show up here. When you are seeing this list and you click, let me pick that one. So if you go to this one, if you click on this project website, that there's a website, if you click, yeah, because it's hard to read, right? So let me reduce the resolution. It's just the font is small. It's a control plus. I'm going to scale up so okay, let me do one thing. For now, this is all I want to say about packages, but for the screen, let me try one thing. Maybe hmm. Let's see. Can you read this? Okay. Right. More scale. Okay. Let me put 1.5. Is that better? So yeah, it's one side. But yeah, so if you go through the package manager, the list of packages, if you look at this project website on the other side, it will link to these docs pages that I'm telling you about. So you can also just go there, and they should most of them should be populated. And also, if you now put something, I don't know, create window, we'll discuss. View help is also, because of all this, that's been the main goal, is that this should also be populated. And again, this format is not great. This will change because it looks overly technical. We're discussing a lot of this, but at least you get, if you scroll down a little bit, at least you get like the properties listed with some things. And most importantly, it's one thing I want to show. You see Bone Vision resources. I'm not sure. This might or might not work actually, because Bone Vision is a bit. You say, yeah, this shows you to send you to the Bone Vision page, which is also good. Connect this from there. But let me just show another one. Let me say, for example, load resources. Yeah, this should work. You help. So on the methods here, the only thing I wanted to highlight, a lot of people ask about how do I know which inputs are arrive to the node. So if you click view help on the node and scroll down to the list of methods, this process methods will contain the acceptable inputs. So if you observable, we don't need to go into all the details, but basically this takes a sequence of resource configuration collection, which you don't know what it is, but if you click on it, you can click and then it tells you what it is. Again, there's properties and things you can do with it. And again, not necessarily enough yet, but just to say this would be how you index it going forward, and hopefully these things will get populated more and more and more, so that you can discover things just by the help file. Yeah. Okay, that's it. That's what I wanted to say about
Update for pre-existing workflows. So if you have a pre-existing workflow,
Yes.
which will name in these ways, you'll be upload the functions.
Yes. They all follow the same logic. And in fact, this will work even because these are just websites that are published. They should, well, for really old ones, maybe not, because they're using old packages. The old packages might not have might not have the correct URL, because the URLs are extracted from the package. So in the package metadata, there needs to be the URL. If it's not, if there isn't, then you won't see it. You don't need a new version of box. So this has been existed since 2.8 or 2.7-ish. I think 2.7. 2.7. I think at least 2.7 will have the help browser. But yes. Yeah. But we'll discuss that too, because I highly recommend, maybe Tom already talked about this, but I highly recommend you install the system bonsai now to 2.9, because now there's this feature we discussed of when you double click, if you have environments that, well, won't necessarily need to talk about this all today, but I think moving forward, installing on the system 2.9 should highly recommend it from my side. But yeah. Okay.
That's going to be challenging. Still editing like environments.
Yeah, we'll go. We can go.
And then sounds like broken. Of course, that's right.
Yeah. Yeah, it's fine. This will be a process. It's 2.9 is quite new. It's literally a month old. So it's not. Things will take time. It's officially released. Yeah, it's officially a month ago. And there will be patches. There's already like tons of bugs, but it'll be end of this month. It'll be 2.9.1. So it's fixing one little things. But anyway, okay. But this is just a aside. I wanted to say, but what I discussed with Aman we should talk about today is this new tool, SGEN, Bonsai SGEN, that SGEN stands for Serializer Generator Tool. It's a mouthful. There's also a website for it, but it's a bit technical. There's stuff in there. It explains the motivation. It explains how to use it. It's a bit technical. So I wanted today to kind of go at it in a slightly different approach and explain where it fits in experiments, because it's actually quite important going forward. I feel its role is going to increase a lot. So to motivate it, specifically in the context of vision psychophysics tasks, I decided to start with a tutorial on vision psychophysics. So this is a tutorial that exists on the Bonsai documentation. If you just go to tutorials, there's vision psychophysics, and you'll see this. And if you walk through the entire tutorial, this basically tells you how to build a kind of a 2AFC task in the kind of fish discrimination. Yeah, I can make the test bigger before. Yeah. So, yeah. So yeah. So basically, I mean, this is a long tutorial. We could make it. I'm happy to answer questions about it. But basically, you end up. So if you go through the whole thing, you end up with a task where you can collect feedback on choices. So let me actually load that because I have it here. So this should be the final state. If you walk through the entire tutorial, you end up with this. So you should end up with something that looks like this. I'm gonna start it. But there's, I think, 2 ratings and slightly different orientations, and you ask A or B. This is all very crude. And I click left or right to indicate A or B, and then you go at it again, and that's basically it. That's what you end up. Yeah, you get these choices. And you could add on top logging and all of this. But what I wanted to ask, or what I wanted to motivate to launch the discussion is, well, how do you parameterize this task? Because basically in here, so this is the task structure. So this all the stuff here is the infrastructure. So you create a one vision window with the resources, a render loop, a random number generator for angles, and then you have a task, which is basically you have the ITI, then it shows the reference grading, which is basically a random orientation grading that has something inside, which we can look. And then there's a blank period, and then there's a test grading. There's again another random orientation grading, and then there's a response. This is basically drawing the text A or B, and then there's some keys you have to press, and then there's a feedback on your response, like whether it was correct or not. So it shows a quad of the appropriate color. Now the issue here, so the task is done in a way, like many things we could tweak, but the problem is there's many parameters here. Like this is hard coded in the workflow, right? Like the blank period, there's a delay here, which is hard coded. It's 2 times. So if you want to change it, you have to go inside, change it by hand, which you can. But the problem is you may want to change it parametrically, trial by trial, or based on some distribution, or based on more complicated things. And you want to keep a log of that too. So there's logs of the behaviors that humans or animals are doing, but there's also logs of the parameters, like trial by trial, what's happening. And currently, this was not ideal. It was done to, so I can show you how we would do it so far. So you could do things like, okay, you go inside a blank period, you can externalize the do time property, give it a name. So this do time, we could call it the blank periods, something like that. And then that means that in here, this node now has the blank period on the top. And if you externalize it further, then actually, this is just one note aside, but so externalizing these properties make the properties available at the higher level. And if you bring them all the way to the top, then when you click on the blank space, the properties are here, listed here. And you can go on with this. So for example, let's say I wanted to change the response keys. This is left and right. So I could say externalize the key. This is now called the key for, or I don't know, key for A, the key for B. You can keep going doing this. And now you go to the top. So now response has the key for A and key for B. So left and right is more visible. We can make it even more. You could externalize, actually, you can externalize all of them. You externalize all properties. And then, so now you have blank period this. And you can go on and on. So this, the other thing I want to show, just because this is useful, you can group these into categories. So this could be, I don't know, blank category. This could be the, you can actually go inside this. You can say these are all the response category. If you group them by categories, then they will be grouped similarly in the top level. You can, and so the thing is, and by the way, these are also parameterizable on the command line. So if you call your workflow from the command line, you can pass properties to these things. So you can, so this helps a little bit. The point is that this was there, this is already there for a long time. It helps a little bit, but it doesn't necessarily help solve our original problem, which is, okay, now I want to do this trial by trial. I want to pass a file, let's say, presumably of configurations for things, of all this stuff, and populate, and then, yeah, run through these trials, but now pulling data from those parameters, and how to do that. So the way you do it so far, let's say, for example, you wanted to load in a CSV file, like a text file where each row is a trial, all the parameters. So you could do that too. So you could put a CSV reader with some file, and then you could create a pattern. So this CSV allows you to parse, this CSV reader allows you to parse the file however you want. So you can do, I don't know, let's say I have my blank period is a number, floating point number, milliseconds, for example, but then I also want to have a let's say, well, the keys are not useful. What else? Oh, let's say the angle. It's just one more parameter. So this is already, yeah, this okay, let's say we want to parameterize the distribution. So let's say it's continuous uniform. So you have lower and upper. This is uniform distribution of angles, lower and upper. So let's say we want to do that. So we want to externalize all properties. Easily slow. So you can call this is distribution. Distribution. Yeah, lower and upper. And so let's say we wanted to parameterize that. So we would have to put that inside a CSV here. So let's say we have now a number, again, more numbers separated by spaces, for example. So put three numbers, which is the time for the blank, and then the numbers for the distribution, lower and upper, let's say. And so you end up with an output of these things, which is three floats that are not named, and you now have to map them to places. So you could save all this in a list. Well, there's many ways to do this, but you would you'd have to store these somewhere and then map them to the properties here. So for example, you can take the way I would do this is for every, well, one way to do this is you could say for every trial. So you could put all this instead of doing the repeats here, you can basically create the trials from each row of the CSV creates a trial. This would be create trial. And then you put it here. You don't need the repeats. So basically this thing now runs for every row in the CSV, creates a trial, and you run the trials in sequence one by one. And now here you would have the input would be your three numbers. And you could so you could save this in a trial parameters. And then from the trial parameters, you take, let's say, the first one and you pass it to the blank period. And then you take second one and you could do other things. And maybe this is not even organized the best way. But my point here is this works and you could do it this way. It's not extremely satisfying because CSV Reader, first of all, doesn't give you names to these things. So you have to kind of, well, you can give them names. And by the way, another thing, I can show that how you could do that. So using expression transform, and by the way, this now has a vast help. It's another thing that tells you exactly what you can write inside, and it even tells you how to, I think if I go to the top, it's even showing here, or should be a list. Oh, here maybe. No. Let me just leave it on. Yeah, so if you go here, you can look at data object initializers. So this explains to you, for example, how you can rename like item one, like things into other things. So you can copy this thing and you could put it inside here. Here. We could call this now can be a blank period. This could be the lower angle. Now it's complaining because I renamed the names, but now you end up with something that has a blank period, lower angle, upper angle. So there's actually names attached to them. And now you can use those names when you pull things from it. So that these things have names somehow. So this, again, you could all do. There's still problems with this, which is, well, CSV, there's many issues here. So one thing is these types you create now have names. They can be saved and it will save them with the name. So if you were to write, for example, this to a CSV writer, the things that are pulled from the trials. For example, let's say that you do something that is quite common is you take your CSV list of trials and you shuffle it. So you can do permutation so that you shuffle all the rows in the CSV. And then you could save that. So you could say, okay, now I want to save for every time I start a trial, I want to save the trial that I got the exact order to another file. So if you save it to a CSV writer, it would, and you say include header, for example, it would actually include the names you wrote these things would be also included in the name. So at least you would have something that makes some sense. What is
Does it seem to be one on each time, or does it say the whole list? And then
in this way it would say the whole list in the beginning, yeah. So you'd have to put it after or inside this. I mean, there's many ways to do this.
that's fine.
Yeah, you'd have to save it, you'd have to wait. You could wait until either the end of the trial. So let's say, for example, the trial stops. If we go for all this at the very end, you could say take the last value. The last value of the sequence will tell you when the sequence is over. I don't know if this tells you the result. Maybe there's a Boolean, probably indicates whether the trial was successful or not. So you could do something like, okay, take the result of the trial, and now, for example, zip it with the trial parameters, and then you send it to the output. So for example, you would now have a file that has the Boolean and the blank period, lower angle, whatever. So you could end up, and this would be per trial. So then if you were to save that to a CSV writer and include a header, give you the results or something. CSV, that's actually, it's grade one, just trial CSV. So let's say, say I put, oh, yeah, I could remove the seconds. That's it. These numbers are not important because I'm not even using them. Yeah. So these are the trials, for example, 3 trials, and you read from the 3 trials, and you rename them, and a blank period. I actually need to do something here to make this. These are milliseconds, so I'm just going to say. This is also in the documentation. Save now. And there will be even better. Okay, so if I run this now, it should run 3 trials. Something didn't match the input parameter because it probably saved it with I was editing in Excel. So Excel, I don't even know what
will be a comma tab. That's a something about.
is a tab, yeah. Yeah, it uses tabs by default. You can change it. It's just trying to be clever. It's just separated by spaces. I run it. Oh, it already exists. Yeah, overwrite for now. It's all details. Now it's 3 trials. I'm not doing anything with the angles, but it's just gonna do 3 trials with some blank, figurable blank period, and the second one should be faster. Like that. Yeah, now it's over, and now if we go to the results, yes, they should contain. So they contain the results of the trial. We didn't give names to them. You can. Huh? Oh.
Oh, my bad.
Sorry. Yeah, so we ended up with this CSV file that has the result of the of this. And yeah, you could give names to things and so on. Okay, so you could kind of do something like this with enough effort and patience. You could pull through this, but there's problems that remain. Specifically, CSVs are hard to manage because yeah, there's no verification. If you get a row wrong, you don't know until you've hit that row. Well, actually, maybe the whole thing gets loaded in the beginning, but you might, yeah, it's hard to interpret. And hard to change if you start now having multiple levels, which is now which can be quite common. Let's say this is a list of trials, but let's say this was, I wanted to create blocks. And blocks have their own list of trials and you can have meta parameters that change per block and others. And so you might want to have a more hierarchical structure that describes your complicated task. So to achieve that with CSVs, it's possible. Like you can add another column that says this is the block, and then you can do clever things. But then it becomes even harder to validate, and it's easy to get wrong. And then every time you have to go through this, you'd have to change your code because these renamings and things, you have to go here and actually change them still. And the last thing is, if you wanted to interleave some things you want to go, because the other thing that can happen is, as your experiment evolves, you may want to have certain parameters come from the file, but certain others are computed online. And you might want to actually decide, without having to change your data formats, you might want to decide in the middle to say, oh, now this time I want to run this one. I want to fix this one. I don't want to care. And to do that with this method would be more annoying because there's no way to create. It's possible, but again, you have to write more code into it, and you'd have to.
I think when in a standard say script, we might say for this block or this file,
Exactly, yeah.
and then each block might have some parameter vary for each file, might have a place statement in the file saying if you have doing this and do this,
Yeah.
take time for this.
Yeah.
I think you're saying you can articulate CSV file that can capture all those dependencies.
Yeah, it can get messy. It'll be a messy one. It may not even, it may be possible, but it will be at the very least a messy one.
It's like you've written a workflow, you've got 3 floats that parameterize and you know what those floats do because you spent prioritizing. Passing it to someone else then to follow through the branches, figure out the version. And then you can do this expression transfer in the unknowns. Now people have a bit more what's happening, but it's about playing parameterizing the CSV, which again, you know what the ways of problems mean. It might not be immediately obvious to someone who's using the
Yeah.
They need to spend time.
Yeah.
Calculating what you do, and otherwise they have to look with a CSV and follow everything through.
Yeah.
Sharing with your future self. Yeah.
And yeah, this is a great point because also the experiment doesn't stop here because then you have to analyze the data. So the CSV that I produced, you also have to parse it in Python, for example, or MATLAB, whatever, and then you need to do a similar thing again to know, okay, yeah, as Andrew was describing. So it's not a great experience. And so the other thing you can do, so the way professional programmers in C# would solve this is they would solve all these problems by formalizing what they call a domain model in code. So they would write C# code. So this is now, I'm going to switch briefly to the documentation of, I'm not going to go into much detail here, but this is where actually this is where the discussion of Bonsai SGEN begins. So I've motivated it, but where the discussion of the documentation begins is data definition. So the problem is that one thing you might notice in Bonsai, what does this boil down to? There is no way in Bonsai right now of defining a custom data type. You cannot. So well, you can, but you can. So the best you can do is what I was defining here, which is you define this new thing, you give them names. But this is not a proper type in all the senses of, if you go to Python, create a class, or go to MATLAB, create a record, like structured record with things like it. There's no way to do that in Bonsai. But that's actually a very useful common thing in a language to do. You want to define types that represent your model, like your trials have these properties, your blocks have these properties, they relate to each other in this way. So one object might have a list. So like, let's say that the block object might have a list of trials, and the trial has this list of properties and these things. And then you have rules that are defined in the language to how they are loaded from files and written to files. Bonsai did not have. Class, yeah, class, record, yeah, all this, yeah, names have been, even within programming, these are known as record types because they come from records in a database. Or, like it's a long history of things, but basically essentially it's a class. Yeah. So you cannot do, you could not within Bonsai itself. You can if you go down to C#. I'm gonna skip that part a bit, but I can. So well, not I won't skip it. I'll just show you briefly. But for example, you can create in Bonsai, you can create these C# sources, which are basically, so let's say this is my, okay, create, I'm gonna create random grading, and grading trial, or create random grading parameters, something like that. Records. Okay, record. This is what it is. So you could this is now you've left Bonsai and you're in C# land, and in here you could write things. So you could write your properties here. So let's say I have my double, that is my blank period. This might not even make sense given what I'm, but just writing some properties down. You could write the lower angle and the upper angle, just write these things. And then, so these would allow you, so if I now reload the extensions and I look at this create random grading record, you have the properties here conveniently in Bonsai. So this is advantages because you can now edit them by hand. So if you wanted to create things dynamically and then save them, this would also be saved to CSV with the exact same structure. So if you wanted to create this randomly in Bonsai, and then this would be now possible, you'd need to also make sure when this is returned that you create a random grading record with these things, just showing once, just so we can move on, because this is also annoying. The annoying thing is, so what is this doing now that I wrote here, is that what I'm essentially saying is that this is a constructor thing. So yeah, I'm not going to ask you to go into C#. So that's why I want to go gloss a bit over this, not too much, but basically now you have an operator in Bonsai that you can fill with parameters, and the output would be an object of that type with the same parameters, and you'd basically be creating these things. But again, so this was the closest you had, and this you could make as complicated as you want. So this could have ways to read and write from files. You could write, but now basically writing in C#. That's the thing. There's no easy way. You just have to kind of go there.
The question around the classes, could you also define callback functions similar in those classes, or?
Yeah. You can do whatever you want. I mean, C#, yeah, we could go, there's many things you could do in this approach. You could respond to, so this is now an operator in Bonsai. So you could have inputs to this node, and you could define how those inputs create things. And there's tons, then it's like the entire discussion of how to create a custom Bonsai operator. You can do a sort of amount with it, everything you want. But the disadvantage is, yeah. But the disadvantage is you're writing in C#. You're writing code. You have to write code. There was no easy way. But this was the way. Like if there was a way to define a custom data type, that type was defined in C#, and you'd have to write that. Which is not great for reasons that, well, most experimentalists will not be familiar with C#, and it's not necessarily the language you use for the analysis. So you'd have to kind of learn two languages. It also creates this issue of its code. So different people will do it in different ways. So interoperability is compromised because now you have a class someone did, and then another class someone else did, and then those two classes will not connect with each other. But it's not even just connecting in terms of converting. They haven't been designed in the same fundamental way. So there's no standard. So that's why And so this is why we talked about, you can create these things, but it's not great. You could create a custom scripting extension, also not great. It's basically the example that I gave. So we were still kind of hashing our ways how to do it correctly, and we then came up around about a year and a half ago. We hit up this other idea, which was to, instead of inventing yet another way, because we could have made, okay, let's make another language in Bonsai to make creating data types easy. This is yet another language. You put it inside Bonsai, and you could have all kind of nice rules, but it would be yet another language. So what we decided to do is, well, let's not do that, and let's pick an existing standard that would be richer to help us define these things. And what we picked is JSON schema. So this is, again, yet another language, but as you'll see, as I hope you'll see by the end of this, there's numerous advantages of JSON schema, including compatibility with your existing languages. The JSON schema is basically huge. Is like one of the probably the biggest data exchange standard currently in use. It's used in both to exchange data in databases, also on the web. It's fully supported by Python. Python can just eat one of these in one line. We'll give you everything as a nice Python class. MATLAB as well, and all of this. So for that reason, we adopted JSON schema as the way to define types for Bonsai using this SGEN. So how does this work? And again, you don't have to write. You don't even have to write this necessarily, but basically, JSON schema is again a language in JSON where you describe just properties of objects and what they contain and what types they have. And there's even more things you can write, like you can add metadata like descriptions of the properties, so that when you are using them, they are documented. So it includes a layer for documentation. So this would be an example of this person JSON. And just to show you, before we go into too much detail on this, I'm just going to copy this. This is a definition of this person object, but we can adapt it to do our own. So let me just stop this for a moment. Oops. Let me stop this for a moment. And stop this. And let's go back to the terminal. And so to install SGEN, so we can use this, you have to run these two things. You can run them in any folder you have. I'm just going to create. We can discuss more about what these things are in a moment later. But so this would install SGEN. So now we can just call .NET Bonsai SGEN. It has a little help file explaining how it works. But essentially what it wants is you to give it a schema, and then it also wants you to give it, and actually that's it, I think. So let's now create our schema. Person JSON, and I'm going to copy that definition in there. This is definition of our type, but well, actually we don't need to call it. We can call it our rating record. Random rating example. Rating trial, something like that. And these would be the blank periods. Oh, actually, this is missing something. Realizing I need to update the examples so that you have automatic completion where you can write. So there's a missing thing in the docs, but so let's say we have a number, and then you have the lower angle, which is also a number, and the upper angle. which is also a number. And we don't need the rest. So we just have this. Just the spot trial task. Something. So now if I call .NET SGEN that's JSON. So this now generated this file, data schema I generated, which basically contains a similar code to what I wrote by hand, with the blank period, lower angle, upper angle, and also the bonsai operators of how these things can get created. It also has nice things of like when you print this, it kind of shows you on the visualizers, it shows you the things in a nice formatted way and so on. And importantly, it includes code to serialize and deserialize this to either, actually by default is YAML, but just JSON. So now this will include ways to read and write records of this type to and from JSON. So if I now drop this inside my extensions, I just move this inside the extensions so that it can be used by Bonsai. I'm gonna write in this thing again. Oh, I need to install. Yeah. Let's install the. Yeah, actually, yes. I need to. Yeah, this I think is in the documentation for SGEN. The other thing you need to do is you need to add this thing to your extensions. If you read through this, don't worry, following exactly now what I'm doing, but it's explained there how actually I added the wrong one. I'm inventing a bit. I want should have both. Both? No. Okay. Actually, it should be here. Yeah, this one. Might as well put both. Actually, I might need. Okay, so now if I do what I call it grading trial, I'm going to delete my manually made thing. And in the grading trial, I have the same things. But now, so this has the same things, but you can now read and write. So you can write this to a JSON file, or you can take a JSON file and do the opposite, reload it to this. Now, the advantage here, let me just expand this a bit. One last thing I want to write here is if you could say that you wanted your entire, this is just one object, the grading trial. But you could create an entire structure of your task in here. So you could have in JSON schema, you can create your root object can be a list of trials, for example. So you could just say what's in here instead of the properties. This is now going to be my task, and my properties here will be, so I have my trials on the side, and then the properties would be these things. Properties of the objects inside. And if you now, oops. Run this. So you end up with a task. there is a list of trials, and each trials trials, and so inside, so if I now run this again, I run it. We'll now create a task. So if you now create a task, the task has a list of trials, and each trial has has these blank periods. And so the advantage here is that this JSON schema now is formalizing your type structure in the it's not the CSV. There's no contract. You're not saying what the types of the columns are. At most you're saying the names, and you cannot create any hierarchical relationship between them. In here you can structure this however you want. It's basically you can even make references to them, so you can create. I mean, there's a whole. Where we are struggling right now is essentially how to. It's hard to explain this in a short time, purely because the JSON schema by itself is a massive field. So we could describe here. But the main advantage that I also see here is you can also write instead of writing these by hand. So the last thing I wanted to show is you can write these from another language like Python or MATLAB. So you don't need to start with writing. You don't need to learn JSON schema. You can use an existing language. So I'll try to show that now. So create a folder here, just so we are kind of go there. Okay. Install. So there's many modules for this, and it's a bit different for each language, but you can install Pydantic. Pydantic is a module, a package in Python that allows you to create these schemas, and you can now create a class. Now I'm going to create my task in Python. Bring it up correctly. No, hang on. Oops, I put it in the wrong place. Yes. Sorry about that. And get it automatically. A lot of glare. Should have picked it up, but it didn't. Interpreter path. Where? Okay. So we could create our breaking, like our trial. So we could write, I'm just gonna write again the class. So I'm just gonna say this is a blank. There will be a blank period, which is a number. Is Now from this, you can actually ask, let's see if this is already. Usage may not be there actually, and I should add some. Yeah, there might. Yeah, let's pull it up from because I always forget how. Yeah, there's one thing I need to put in here. Easiest might be if you give me an example where it oh, yeah, where we upper one. It's important because I think it will be nice for people to be able to know how to create this from. It's this was then that's from scripts. Well, should be overly complicated, but uh,
The buyer was one of them dividing it and having to build it up or saved documents. When you save this process, it happen. Load that directly from to a lot of Jason, you can load directly into a highlighted level to the analysis, but I haven't done it too much. Yeah. I'm not sure where you're writing it. Yes, you're not too much into Jason.
yeah, exactly. That's the advantage. So let's
Especially
see.
on the side, if you want using identity, you find all of those. Is there a real difference to a data class and identity? But also kind of data classes where.
Yes, yeah. There's data classes and Pydantic. Yeah, it's possible to. You can also generate JSON schemas from those. Pydantic has some advantages in that they validate the validation of Pydantic is more. You can do it more complicated. It's more you can do more things with Pydantic in terms of validation and with data classes. But let me just try to run because I think I'm just blanking on one thing which I want to know because it's really. Let me just try to find just one line. Oh yeah, it's just model so model. Actually, I think we'll probably just do trial. Model JSON schema, yeah. Systems. And then actually just to sprint this. This will be JSON. Do the schema and then just do JSON. Schema. Okay, so if we run this, oops. No, yeah, so this.
You just heard into a style, I guess.
Yeah, there's we could make it inside here. Basically, if we were to create our task JSON So basically, if you were, I think, sorry, let me just put, because this is, there's an option here you can say, I think, indented. There's somewhere, I think maybe in here, we say indent to, just to make it a little bit, yeah, so now it's fully. Yeah.
I don't know how.
Basically, yeah, so let's see.
Generated and before each run, new thing, if you want to run. Yeah, that's what. So, whereas it just. Is there any difference in terms of the vibe coding with like is Claude slash ChatGPT going to be more familiar with the language to help if you're doing it identity versus YAML, or is it so that much I guess, yeah.
I suspect that it'll be identical. It was a bit more expressive, less likely. Based on there's different schemes, there's different syntaxes. They I guess where you specify to your big tool or whatever which case. Adapting it a little bit. Expect.
Anyway, this is the, yeah, so now everything is working. This is the bit that I was missing. So it's basically you take your class that is defined like this. So just class trial has these things. So very succinct. And then you just say trial model JSON schema. So this is because this is a Pydantic based model. All of the models have this function that just generates a JSON schema corresponding to that class. So you get the schema and then just dump it to a file. And yeah, this is just the way to do it in a way that will be correct. And then now once you have this set up, now you can just create, for example, our task now could be another model that now, for example, contains a list of, you could say like the trials is a list of trial, for example. And now what we write the schema of is the schema of the task. So now if we run this, now the schema now is more complicated because it includes a definition of a trial that has the properties of the trial, and then the root, the task itself has a list of trials whose items are these things. And you could import this into, and then you could call SGEN on top of this thing to generate the code for everything. So in fact, if you think of SGEN, if you think of Pydantic and SGEN and JSON schema as just infrastructure, because you'll never be really editing this code. What you'll be editing is essentially this. You'll be editing this, generating a schema from these class models, and then from that JSON schema, generate the corresponding bonsai C# code. And then you would basically end up with a pipeline where you can save, like in Python, you can create a structure of these of these objects. For example, write them into a JSON file, and then you can read them in Bonsai, do things with them already with names, with the types, with everything, and then do the reverse. So you can also from Bonsai generate a JSON file or a YAML file, and then read that into Python directly into these classes. So you don't have to do, so there's no need to validate back and forth whether you did the right thing or whether you mistaken the column for something else. Because essentially here you'll have this is like your contract. This is basically how things are laid out.
So the only exactly go wrong is if your Python switch and your Bonsai switch start evolving the nodes independently. So I think the names here are unique in that, right? So
Names have to be unique.
it
Yeah,
will tell itself
it will
what's
tell itself. Yeah. Exactly. That's the other advantage, because here you Python is validating this code, so that names need to be unique, or I mean, the things can reference to each other. You can have objects that have references to other types, but yeah, you can only define one type with one name and things like that. So that will, yeah, that should be valid as long as your Python code is valid. The model should be valid. And actually, let me just do one thing. So we need to do. There's a little quirk. I'll leave it here for the. This is a compatibility thing that I've been trying to push with Pydantic to solve this, but it's not. But I'll leave it here as a little. This will make things be easier. But now if we take this JSON, so now I've generated a JSON. Yeah.
So you have to write a file stuff.
Yeah.
Then decide that all the one is fine. And go down forward.
Yeah.
You don't have to recode the actually. You can still just use on the
Yes. Yeah. And you can add more things here. You can add more stuff here. They will open up. So you'd have more things in the model, but if you're not using them, it doesn't
You
matter.
don't have to worry about it.
No. Yeah. You don't have to worry about any of that.
If you, for example, deleted something that it was expecting, then presumably that would bring something, but also presumably you want to bring something.
Yeah, so for example, if you wanted to now write, so I'm gonna do, so this is generating the schema, but now let's say I want to generate trials. I'm doing everything in one Python script, just but let's say I want to have our trials be I don't know, for I in range, consider 10 trials. I'm gonna do I'm gonna create a trial with blank period I times 2 for some reason, and 0 I squared. Doesn't make any sense, but and it it complex numbers, you probably have to represent them as a structure. I don't know if it's built in, but you can represent, basically you just have two components. Yeah, but it's just another object. You might even be able to find packages in Python that already have these things defined and then put them into Pydantic. It might work. I would be surprised if it doesn't exist already. But I've never done it, so I don't know. Okay, but let me actually try this. So past my trials are this thing. Is it trials? No, trials with a T, because trials. Yeah, so now I created a bunch of trials, which is a for loop, and now I can do the same thing. So just JSON dumps trials. Argument. So this might be just trial. Or we're given. I think it might actually be asking me for. I think it's just it wants me to be explicit. I think so. Fair enough. It really just wants me to be explicit. Okay. Use of type tasks not JSON serializable. Of course it is. Oh, you have to do, sorry, trials dot to, what is it? Model dump JSON, I think. Yes, you can write the JSON schema. String, yes. So you might not even need this. This might just give you the JSON. Yeah, so now you have these, actually, let me indent to. Yeah, so now it generates, this would be a generation of a list of trials. And so now the point being that if I now take, yeah, let me write this to another file. Trials, JSON. So if I put this in my thingy, and now, yeah, and now if I try to load, now I have this trials JSON, which is all the things that I've written. And now if I go to Bonsai, and I run sub physics, and I'm going to read the JSON. So this is inside schemas, my trials. So I read all the text in that thing, and I can read using the data schema. You can deserialize the task, so you can pick what you want, the trial or a task. And I want to deserialize the entire task from this thing. Yeah, it's just another load and save. It's like the opposite. Deserialize, serial. Yeah, it's a technical jargon from. A serializer is something that takes an object in memory and serializes it into a file or string, or usually a format that you can persist. And then deserialize it is a reverse process. Yeah, it's you'll come across it if you it's jargon, sadly, but it's basically load and save.
Serialize being load and deserialize.
No, deserialize being load. Yeah, so
Deserialize.
yeah, deserialize being load. Yeah, serialize is. Yeah, probably. Yeah. It's yeah, these names have long histories of confusion, but yeah, but basically, if we do this, then we could so this will give me the task, which has a list of trials. And now for each trial, I can create my trial. So I can basically duplicate this. So I could do all the things before. So I could so I don't care about this now. I can take the trials, shuffle them. I can now my trial. So now this is, so what is in here? Here is a list So actually I need to, this is the list of trials. I need to actually, so I unfold the list of trials. So I get a trial and I get a sequence of trials. And then for each trial, so I shuffle that sequence and then and then everything that I wrote before works because the blank period is still there. I've been using the same system names. And so this in principle should work. Oh, it's being used. Oh, it's open in Excel. Excel doesn't like that. If I run this, it should still, well, it's not doing anything exciting, but it should still run. I guess this time it should be 10 trials because I did. Oh,
Each trial will take 1 second.
20, something like that. Oh no, it's 20. No, actually, no, it's the blank period. It's just the blank period. Actually, the intertrial interval didn't parameterize that. Yeah, so it's, and actually it's in milliseconds, so it's not that bad. Didn't specify that. So maybe 10 trials, and then I should, and then, but then what I want to show finally is how you could create for the logging to finish the whole thing. Yes. Yeah. Save that. Yeah, and then I want to load it in Python. So I want to do the whole process, which is basically now, okay, now this should be done. So we have our results, fine. So let's actually see if it makes any sense. Yeah, so 6, 16, 8, 2, 12, 18. So yeah, the numbers are increasing. These are this and this number should be the square of that number. Sorry, it's I times 2. No, it's the double. So I wrote I times 2. So this is double of the number. So 3 and then square of the number. So 3, double 6, 9, yeah, 16, 64. Yeah. It's similar anything. But the point, well, now I'm gonna do less trials. Just go back to our 3. But the point is I want to add another thing, which is my trial results. And again, this is now we're getting into a domain where this is now up to you deciding whatever it is. But let's say my trial result is just I have my I don't know results.
Before you go, so
Yeah.
is it necessary to specify what log event the trial result?
I will yeah, we'll go, yeah, that's
But without the
well, my argument is you want to do it here because you want this to be part of the entire
so if you decide you want to log something from the script and go back to JSON file and pass.
So the advantage of being that is that then whatever you write in Bouncer will be immediately importable into Python without doing anything. So basically the same way that I'm saying here, like, so I generate an object in Python and I write it into JSON, you can do the reverse. So you can say I have a bunch of JSON and now read it into.
Part of it, you're basically going to have this Python when you're building this, you're going to have Python console and you have to add Python as well outside events. You can't dynamically add events.
You can, I mean, depends on how you create these models. Like, well, we can, this then goes deep in how you define this, but you could define something that says, if you wanted to go the old school approach, could be something like, I have my logging format is just something that has an event code and the string. And then in Python, in Bonsa, you can write whatever event code you want and things like that without having to change anything. So depend. So I guess what I'm trying to say is your models could be more prescriptive or they could be more loose. You just say, I have a code. So you can have like one schema that kind of is very generic. So you don't have. So it depends on how. Yeah, again, how prescriptive you want to be. These things. But yeah, if you have now this trial result, so this would now be, and again, this is now the interesting bit about reusing things, because what I did here is I defined a trial result class that is basically a class that has a result, which is a Boolean, plus a trial, just trial parameters inside. So you just define, when it defines, it's like an object that is these two things combined. And so now, actually, this is a dictionary. In this case, this is fully detached, so I need to put the trial results separately. And actually see something. I have just one question here. Let me save this. So trial. Let me just make sure that this was added. Reference template. I just want to merge these things. Actually, I want to try to simplify this. Allow me just one more search to see. Oh, nice. You can just do this way. Let's see if this works. I would be surprised if this works, but that would be great. This might not work, but I'd be surprised if this works. So apparently this is how you merge dictionaries in Python. You just say in Python 3.9 or greater, you just do z equals x pipe or y, and then it just merges the dictionary, which is interesting. That's funny. I somehow don't use this. Merge method. JSON merge. So I just want to do, there must be a way to do this. There's more. Actually, don't want to, I just want to do merge. Sorry. Merge. Oh, actually, I'm going to cheat a little bit on my model. So I have task, and the task results. Sorry, I'm just cheating a little bit here just to trial result. Just to jump one step that I will try to understand better later, but there must be a better way to do this than what I did. This will work all the way, all the same. So now if we go to our task JSON, we have a task, a trial, and we have the trial results. So all of them appear in here with the booleans and all that. And now if I again generate code, drop it in there. So we don't even need to see what it is. We trust that it's automatically generated. And then we run set the physics styles. So now we change the schema dramatically, but you see nothing broke. So like it's still the same thing. I'm still serializing the task. And then now inside my trial, so when I do this zip here, what I have here is I have a trial here, automatic. So this is interesting because like we've changed a bunch of things, right? But now in our zip, the trial parameters are now a formalized data schema trial. And I have my Boolean here. The only thing I need to do now is create the trial result, and I can just do that. So, so this trial result has the result and the trial parameters. So you can just now directly pipe them. You can get them from, so the result you get from the zip Boolean, and the trial parameters you get from the trial that was there. So now this will basically create a trial result, and that's what you're going to send out. So now the output of psychophysics is a sequence of trial results. And now instead of CSV writer, we can just do serialize the JSON, and then we write it out. So now I write it out. The interesting thing, there's an interesting thing here, which is how do you put, but okay, let me just, let's just do, I'm going to do something simple for now. Let's just do one trial, because I want to stop this after one trial, just to discuss one thing. Let's just do one trial. It's gonna do all this, and then it stops. So we end up with our trial JSON, which is, yeah, this line result. And the point now is this can be imported. So I just want to do it with one to begin with. So if we now do SDR. So yeah, just take, yeah.
Try to program anything, so. Right.
Yeah, you can do that. Yeah, this is what it opens up, is you can do all kinds of things. Because this is essentially, this is not just a definition of types, but also interoperation between languages and things, and you can send this through also through the network and things like that. Because this is, yeah, there's tons of things to discuss here, but it just, so if I just do open, so I'm just going to open the JSON that I wrote. And I'm going to write the results, and I think we just write JSON was JSON. Just write JSON load F data. First couple of steps. Or print the results dot this is a result. Actually, I think we just print the result. That's the results. Results. So yeah, now you just do run that. The JSON. Actually, this is just tracking it. Oh, this actually might be all built in. I said liking my. think it's the path. I just put it there. I'm just gonna put it here. Just so it's oh yeah, that's right. No. Should work. Let's print it, see if it's okay. Yeah, so there's there result false prior pictures, but I want to now load it. So I don't understand. Should be string, byte array. It is a string. Strange. Any. Strange. Mary. Yeah. Actually, probably just want if read. Actually, this is enough. Probably enough. If dot reads. Okay, yeah, there we go. So now it went as that. So if I just write results, this will be, yeah, this is object, but now this is an actual object. So if I write result dot trial parameters dot blank periods, so give me 2. So that's the, yeah, so now you're operating. The important thing here to retain is now we've gone from the data file to a trial result. And this is now an object you can manipulate in Python. So this is a manipulable object.
So once I context that graph is just initially just loading in with the black
The file.
text, then the next line is actually doing the BC lines of that.
Yes. Yeah, this is, yeah, this validate JSON is the deserialize. And actually this validate is not just read, because this is why they call it validate, is it will read and make sure that the file is in, it's like it's correct, like it's the types are good and everything can be interpreted. And then you just, and then it's an object, then it's an object, then you can do whatever you want. One, yeah, I guess we can took longer than I thought, but that's good because we went through everything. One last thing that the reason why I just left, I'll end with this. The reason why I just recorded one trial is when you serialize to JSON, typically in JSON, you can only record one object, single object. But of course, you have many trials. So how do you do this? You can either say, there's 2 approaches. So we can either say, I have a trial result, and now you can have our task results. So you can either make another model, which is now as the results will be a list of the trial results. So you can make another model that is basically as so it's going to be actually as results. So you could do the entire thing again. Everything should be compatible. But now the idea is that on bonsai, on the bonsai side, let me just run that. So everything still works. But on the I've been using the other one without scale. On the other one, so here instead of now having a trial result, you could, and instead of writing things here, you could do the following. You could just say, okay, at the end, this is a sequence of trial results. Let's run through the trials. And you could just say, okay, collect all the trials into a list of results, collect all the results into a list of results, and then save, and then create the task results object. The results, and then serialize that to JSON and write. This would be the results JSON. So now if I run this, now let's discuss the pros and cons of this approach. But this should work. So now I should have multiple trials, just 3 of them that I put in there. This one. Yep. So now if this has worked, we should have the results JSON. So I call that, I think. So this is now a list of, so it's the results which has a list of results. So you could load, if we go to our analysis, we load our results JSON. And now here we put the task results. So instead of reading a single trial, we read the entire task results. And now the print of those results should be results. Oh, I didn't copy it. Results JSON. Yeah, so now it has all the results in here. So we could do, for example, we could do 4 results in results. Print results. Printing in different lines. Yeah, so you have the results here, false, true, something in the parameters of each thing. The issue is, yeah, so this works fine. The only issue here will be that this only gets saved. The way that I made it here, it only gets saved at the end of everything. So we just have to run through the entire thing, and then you have to stop the program. It collects all the lists and then saves everything to a single object. If you want to do streaming, one standard thing we've been doing now is there's a semi-standard called JSON lines, which is it's a way where it's basically a way to have multiple objects per JSON file. So you just write 1 line for each object, and that line is just one entire JSON file per object. So that's to do that, you could just, I think you can literally just not do any of this. So, and then do append to the results. So this will be a trial result.
All the lower end would be 1 file, 5,000 1 file.
Yes. So let me actually use the one thing because it's this thing. So this would be just I'll show you the difference between both. This isn't, no, it's a detail, but it might be relevant. It's just yes, so we separate them so it's easier to understand. But basically, so the idea is you end up with 3 lines. So the difference, let me show you the difference. The difference will be this versus this. And this is not indented, so it's a little bit harder to read, but let me see if I can make it a little bit easier. Result Oops. So it's this versus this. So this is a single object that has a list of results that you write all at once at the end versus this format, which is a list of objects where each object is a line in a JSON file that describes that entry in the
Yes, that's fine in the end. Anyways, just send it into a pandas data frame and don't care about it anymore.
yeah, you can also do that. Yeah, that's the other thing that is nice. So, oh, and by the way, if you use this format, so technically to respect the format, because this is technically not a JSON file, if you do it like this. So they co-opted, but it is a standard, a growingly adopted standard. The way they say you should name it, you should name it JSON L or JSON lines. And for example, VS Code will still understand it. So if I go to JSON L, it still does syntax highlighting, kind of it understands, and most things understand it. It's just not part of the JSON. And pandas understand it. So if what Kieran was saying is totally true. If you want to do your pandas analysis, you could just load this directly into pandas. I think just directly. So if I just do here, you can just do data equals the read JSON. Yeah,
One of the things of this, I feel that, which is really helpful, actually not, you actually have the process before you based on the choose. But we had to play the hard said, this is the contribution, and the play. Generating console script. It's required to present with a students given half of the bring this through this service of time. Type in something little. Doesn't like the console script before the time. Very generic. What those are. It's just like and you can build quite complex stuff like that. Not just a state transition. Set the environment once man, and then you use it as basically the environment. The idea is to get one side workflow just says whatever it is, that has the boundary definition of these things. And also it looks at it's the state transitions, so like the side. And then so you might say they're going to that. And you bring them together. So you can find actually the session for entire information. Not necessarily.
Report for those on the support. Those run the streamer. You have to get rid of it.
okay, but that so yeah, basically just do then with pandas just do read JSON lines through, and then it gives you a table. Cool. So
I guess the more practical, sort of that. I think it's great.
Yeah.
Emotional, I was about to
And stop then. Yeah.